Alrighty, our last and final method for solving quadratics is using the quadratic formula. This is the fifth method we have learned. This is kind of like your surefire method. Works every time. It takes a little while, but it's one you can rely on no matter what the equation looks like. Some of our methods only work with certain problems, but this works every single time. So it gives us the roots, just like all the other methods do. It's a really long blank for the word roots. And the formula is this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you can't really tell, but that's a square right there. I'm going to rewrite it over here so my board is better. B squared minus 4ac all over 2a. Okay, just want to make sure you could tell that that was a square. So, I know that's long and crazy and involved, but it's really, it's actually not so bad. You just are plugging numbers in over and over and over to a, b, and c. You don't have to memorize that formula. You just have to be able to recognize it. It is on the formula chart that you get for STAR, and you do not have to memorize it in my class either. I'll give you a formula chart of some kind. But there is a little song you can use to remember it. It's to the tune of Papa's the Weasel. We'll sing it in class one day. You can even just Google quadratic formula song. I'm sure it's on YouTube. So let's just jump right in. There's really nothing to explain about it other than you just use the formula. So I'm going to start by writing it, and I'm not going to write it every single time. I'm just going to write it this time so that you kind of get used to using it. So there's our formula. Next step is just to start plugging things in, right? Well, first of all, we need to make sure we know what a, b, and c are because it's in standard form, right? So in this case, 2 would be my a. Let's color code these. 5 would be my b. And 3 would be my c, right? So if I come over here to my formula, got x equals, that's always going to be there. The negative's always going to be there. But now b, that was the 5. Okay, plus or minus the square root of b squared. So that means in this case, 5 squared. Minus 4, the 4 is always going to be there, times a times c. Well, a was the 2, and then c was the 3. Okay, all over, so literally a giant fraction bar, 2 times, and then a again, so in this case, 2. Now it's just a giant PEMDAS problem. All I have to do is start PEMDASing, right? So you want to start with the parentheses. In this case, we have a radical symbol that's kind of like our parentheses. We want to just go as far into those parentheses, or the radical sign, as we can. So I'm going to start in here. So 5 squared, well, that's 25, minus 4 times 2 times 3, well, that's 24. So 25 minus 24, that gives me negative 5 plus or minus the square root of 1 all over. I'm going to go ahead and just do 2 times 2 and write 4. That's all right with you. Okay. So then we just work that out, right? Well, x equals negative 5 plus or minus 1, right? Because square root of 1 is 1, all over 4. Well, this branches into 2 answers, okay? The first one would be negative 5 plus 1 over 4, right? Negative 5 plus 1 is negative 4. So negative 4 over 4 is negative 1. There's my first answer. Then the other part of this would be negative 5 minus 1 over 4. Well, negative 5 minus 1 is negative 6 over 4, which is negative 3/2. And there are your 2 roots. So again, if we were to solve this like with graphing, our 2 roots would appear at negative 1 and negative 1 1/2. It's a very tight little graph there. Okay? Hopefully I did that right. Negative 5. Yeah, I think so. Okay. So that was an example. I mean, that's really all it is. I'm honestly going to do one more with you, and then I'm going to pause the video and write all the rest of it in while you practice. That's all it is. Okay? So, next problem. Number 4 here says negative 6x minus 7 equals negative x squared. In order for us to complete this, we need to make sure that we know what a, b, and c are. So we need to first get things into the right position. So I'm going to add x squared over here. So x squared minus 6x minus 7 equals the 0 that I want. Now I'm ready to actually work out the whole formula, okay? So x equals negative b. Well, in this case, that's a negative 6. So negative 6 plus or minus the square root of b squared, which in this case is a negative. So negative 6 squared minus 4 times a, which is a 1, c, which is a negative 7. Sorry. All over 2a, so 2 times 1. Now it's just PEMDAS. So plus, it's a positive 6. I keep trying to write a positive, but you'll know my board. Let's just write a 6. Plus or minus square root of. So again, I'm working this out. Negative 6 squared, whoa. Negative 6 squared is 36. Okay. Now, this side right here, negative 4 times 1 is negative 4. Times negative 7 is positive 28. So really, I have 36 plus 28. See how that works? So that gives me a 64 in here. All over 2. So now, x equals 6 plus or minus 8 all over 2. So that gives me 2 answers. 6 plus 8 is 14. 14 over 2 is 7. There's the first answer. 6 minus 8 is negative 2 over 2, which is negative 1. Here's my second answer. Okay? That's really all it is. So, y'all should be able to actually do 5, 6, and 7 at this point. Now, you're going to run into some weird things, but you should be able to at least plug everything in and get it going, start the PEMDAS process, and I'll kind of come in and pick up when it gets weird and explain what each problem's kind of unique circumstances. But go ahead and try 5, 6, and 7. Remember to put everything on one side to begin with. Notice here on number 7, this is not in the correct order. It should be negative 4x in the middle, and then 7, right? You want to make sure you know what A, B, and C are. So I'm going to go ahead and pause the video. Y'all start working, and I will repause it, or unpause it, I mean, when I have them all worked out. Okay, so on number 5, when you work it out, you should get negative 4 plus or minus the square root of 0 equals 8. Well, the square root of 0 is just 0. So it's a negative 4 plus or minus 0 over 8. Well, whether you're plussing or minusing, nothing's happening. So really, it's just negative 4 over 8, which means we just have one root at negative 1/2. And that happens sometimes whenever you have a graph that's just sitting just on the x-axis, okay? So that one just had one root, and that happens whenever you get a 0 inside of your radical, okay? And we'll talk about that here a little bit more in just a second, okay? Keep on going if you haven't already. I'm going to work out number 6, and I'll come back. Alrighty, on number 6, you work it out, and you should get square root of negative 11 in your radical symbol. Well, we can't take a square root of a negative, which we've talked about a few times now. When you can't take a square root of a negative, that just means your answer is no real solutions. In other words, this is a graph that is floating up above the x-axis, and there are no roots. Alrighty? Okay, number 7. This one is actually pretty good. You just have kind of a weird answer. All right, on number 7, you should get 4 plus or minus the square root of 44 over 2. Remember that this can be changed into 4 plus or minus the square, no, not square root. Sorry. Okay, plus or minus 2 root 11 over 2, right? I should say plus or minus, because I broke 44 into 4 times 11. Now, this type of problem actually is 2 different types of answers, okay? This is one answer, actually. This right here is what we would call your exact answer, okay? This is exactly the answer. Now, we say that because we haven't tried to, like, round it off to a number that we're more comfortable with. If we had an estimated answer, that means you would type it into your calculator and actually get 2 different decimals. So, for example, you get 5.317, which goes on, but we just rounded it off. That's if you do 4 plus 2 root 11 over 2. Or you might get x equals negative 1.317 with a couple extra numbers on the end. And that's if you do 4 minus 2 root 11. Now, these answers, which are also acceptable, are called estimated answers. Okay, and they're called estimated because we did round them off. These numbers actually go on forever. We're the ones that decided to estimate it and stop it at the 7. Okay? Now, these are the same thing. They're the same answer in theory, but one is exact and one is estimated. Okay? So, that's what this is talking about. This little box. Exact answer is when it's left in radical form. okay? Or if it's actually worked out. We also had exact answers on all the other problems. So for example, these are exact answers right here. We just actually could work it out, and it really is exactly 7 and exactly -1. But if it's a square root that's not a perfect square, you have to decide if you want to leave it in a radical form, which would be exact, or if it is rounded to a decimal. Okay, and you have to read the instructions to see what they want. That's the way you know to do one or the other. Okay? All right, the last thing we're going to talk about is this little foldable that I passed out that you're going to glue into your notes packet. And the way it works, you're going to fold the top edge down right here, fold the bottom edge up right here, so that it looks like this, okay? And then you're going to cut along here and along here to make flaps. Do not cut through the whole thing. We've done foldables like this before. You're going to have 4 little flaps that you can open up, but you're not cutting through the whole thing. This is still going to be 1 piece of paper, not 4 pieces of paper, okay? If you need help, just pause the video and come get me to fold it for you. Okay, so the last thing we're going to talk about today is the discriminant. So once you've got your paper folded, open up the flap that says, what is the discriminant, okay? It says, recall, the quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a, right? Well, the discriminant is b squared minus 4ac. You'll notice that it's the part underneath the radical sign. It is not with the radical, it's the part that's underneath it, okay? All the discriminant does is tells you how many solutions to expect, how many roots that graph is going to have, okay? It really doesn't tell you what they are. It's kind of a useless piece of information unless someone says, hey, how many roots are there going to be, okay? So if we look at this first example, so open up the flap that says 2 real solutions right next to it, you'll find this example problem. And let's go ahead and calculate the discriminant. So if I do b squared minus 4ac, that means I've got -4 squared minus 4 times 1 times 3. Again, this is a, b, c. Well, this is 16 minus 12, which is 4, okay? If my discriminant is 4, in other words, if it is a number greater than 1, okay? Well, I guess I shouldn't say that. Number greater than 0, we'll say it that way. Number greater than 0, sorry. I know y'all hate when I do that with the erase. A number greater than 0, not equal to 0, but greater than, then you should have 2 roots, okay? 2 roots, 2 real solutions appear when you have a discriminant that's greater than 0. So if you were to look at this graph, I know it's drawn on yours for you. It's something like, I don't know, something like this or something. You can see that there are 1, 2 roots for this graph. And that is because the discriminant was a whole number, a 4, right? That was underneath my square root symbol. I can take the square root of 4. It's going to give me 2 roots. Now, it would also be okay if it was a 3, right? That's not a perfect square, but I can still take the square root of a 3, so it's going to give me 2 real roots. Okay? Now, look at the bottom flaps. If you open up the one that says 1 real solution, that would be an example like this, okay? b squared minus 4ac. That would be 2 squared minus 4 times 1 times 1. That'd be 4 minus 4. That's 0, okay? If the discriminant is 0, okay, if the number is 0, that means you have 1 root, and 1 root only, okay? And your graph that should already be drawn for you looks something like this, where the root is on the x-axis and it doesn't cross anywhere else, okay? So if the number underneath the radical is a 0, you're going to have 1 root exactly, okay? And then the last example, I don't know if it's a 1, that should be a 3, is having no roots. B squared minus 4ac. So we've got -2 squared minus 4 times 1 times 2. So that is 4 minus 8, which is -4. So if your discriminant is less than 0, then that means you're going to have no roots, no solutions at all, okay? And that means that it's just floating, right? We've seen these before. That means it is up here, not crossing the x-axis, okay? Now again, this doesn't tell you what the roots are, it just tells you how many to expect. So let's kind of explore this further. You've got 3 problems here. We're just going to find the number of solutions, not what they are, just the number of them. So on number 1, let's do b squared minus 4ac. Let's plug in our numbers. So -2 squared minus 4 times 3 times 2. This will be 4 minus, let's see, 4 times 3 is 12 times 2, 24. That gives me -20. that means that there are no real solutions because my discriminant was negative. Okay, when you get a discriminant that's negative, you're not going to have any solutions. Now that's useful because you wouldn't want to go through the whole quadratic formula just to find out that you couldn't have a solution anyways. Okay, let's try number 2. Ooh, that looks weird. This is supposed to say 4/3. Sorry. 4/3 n squared plus 4n equals negative 3. Sorry. So if I add the 3 over, that means I'm going to have 4/3 n squared plus 4n plus 3. There we go. So let's do the discriminant. B squared would be 4 squared minus 4 times 4/3 times c, which is, oops, positive 3. Okay, so 16. This would be minus 16 if you multiply all this together. Okay, just remember, multiplying fractions, you can put them all into fraction form. Then you just do tops times tops. So that would be 48 over 3, which is 16. So 16 minus 16 is 0. And I think back to my foldable. If the discriminant is 0, that means there is one solution. Now, that does not mean it is at 0. That just means there only is one solution. So my graph, it could look like this, where this is my solution and it goes up like this. It could look like this. It could be on the origin. We don't know where it is. We just know that it hits one time. Again, not that helpful because we don't know what it is, but we just know it hits one time. Okay? Y'all try number 3 on your own. I'm going to pause it. Okay, you should get a discriminant of 169, which means that there are 2 solutions. We don't know what they are. We have no clue. Those solutions could be 2 and positive 2. They could be 8 and negative 4. We don't know what they are. We just know that there are 2 of them. It is worth it for us to continue investigating this problem and find what the 2 solutions are. Okay? Y'all, this is a record. Our video is only 17 minutes. Woohoo. Okay, let me know if you have any questions. You have homework to do after this. But you have now learned all 5 methods. Woohoo!